So let's start with the graph of f of x equals 2 to the x power. All right, are we ready? So if you had to figure out what this graph looked like, I think we did this on day one when we looked at exponentials. I know that's been a minute. Yeah. If are they labeled? No. Then you throw it away. I'm not going to dig through it, try to find it. So if I had to graph this, what are some x values?
3.
Do y'all remember doing this? I remember doing this. And then we started here. If I plug in 1 for x, what is 2 to the first? Oh my gosh. 2 to the first power is 2. If I plug in 2 for x, 2 to the second power is 4. If I plugged in 3 for x, 2 to the third power is 8. What if I plugged in 0 for x? 2 to the 0 is 1. All right. What about 2 to the negative first? 0.5 or 1/2. Did you use your calculator? You cheater. What's 2 to the negative second? 1/4 or 0.25. Remember, negative exponents flip the fraction. And we looked at this. So what would be 2 to the negative third? 1/8. Okay, so if we graph these, so I've got 0, 1, I've got 2, 4. Sorry, 0, 1, 1, 2, 2, 4, 3, 8. Then I've got negative 1, 1/2, negative 2, 1/4. You guys remember this graph? And then we talked about it got really, really close to this line, but it didn't cross this line. What do we call that? The asymptote. Has an asymptote at y equals 0. Remember that? Sweet. Okay, now let's graph something else. And let's think about this in the same way that we thought about absolute value functions. You guys remember all of our work with absolute values, which were those V shapes? You remember all that a little bit, maybe? We'll see. All right, what if I had f of x equals 2 to the x plus 1? Hmm? 1 is not the y-intercept. It's not linear. That'd be true if it was linear, but it's not. Look at the original. The original without plus 1 had a y-intercept at 1. Huh? 2? Why would it be 2?
Because I already have 1.
Because you're adding 1 to it. What does this plus 1 do? It does add 1. Graphically, what does that plus 1 do? Shifts the graph up 1. You remember all of our shifts we did? This is on the outside. Outside affects the y's. So it goes up or down. Because it's positive, we're going up 1. And so what would happen to that vertical asymptote, what would happen to that horizontal asymptote that was here? It would also go up 1. The whole graph would just get shifted up 1. We could prove it by like plugging in values, right? But it's not, I don't think it's worth our time. We've seen that before. Let's just plug in a value. What if I plugged in 3? What is 2 to the third? It was 8. Here, what is 2 to the third? 8 plus 1. So now then, this used to have 3, 8, but this graph has 3, 9 on it. Right? It's just up 1. And that follows for any point that you plugged in. All right? What if I had this? What if I had f of x equals 2 to the x minus 1? It's going to go down 1. Which one's going to go down 1? The red graph. What about the vertical asymptote? I keep saying vertical. Dang it! What about the horizontal asymptote? It would also go down 1. The whole graph shifts down 1. Outside. These are outside the function. Outside affects the y's. They do what they look like they should do. Questions there. Okay? What if I had f of x equals 2 raised to the x plus, x plus 3. What's different here? It's plus 3. What else is different about it? It is not on the outside, right? You see how this one looks like it's inside the function? That's the way I call that, inside versus outside. It's not in line. So what happens when we add or subtract on the inside of our function? It changes the x's. What else happens when we change the x's? Huh? The x's, when we change the x's, it does the opposite from what it looks like it's going to do. So a plus 3 would shift the graph.
Down. Left.
Left 3.
Okay.
Left 3. Y'all remember these from absolute values? Remember how I told you like all this stuff that we do you have to remember because it keeps building? Like, it's not going to go away. Guess what you're going to do in algebra 2? The same jump. And guess what you do in pre-cal? The same jump. Okay?
Why do we have to do it again?
Because it gets more difficult. We build on it. But you can't lose this skill. Like this is the second time this year I've already talked about transformations of graphs. And guess what? Later on, we're going to do it again. Okay? Same jump. You got to remember this stuff. The reason I'm harping on you guys right now about that is because I teach pre-cal. And guess what? People don't know what to do when they get to pre-cal. This. They have no idea how to move a graph. And I have to spend way too much time teaching it. Something that they've already seen 2 years before. Anyways, so if this, I'm going to graph my original. 2 to the x looks something like this, right, originally. And so this one, going left 3, means the point that used to be at 0, 1, it's now at negative 3, 1. The point that used to be at 1, 2, it's now at negative 2, 1. The point that used to be at 2, 4, it's now at negative 1, 4. 3, 8 is now 0, 8. You see how all those have shifted left 3. Follow? Maybe? But it didn't shift it up or down. I still have the same horizontal asymptote. Right? Because what happens if you shift a horizontal line left? If I have a line that goes forever like this and I move it left, what happens? Nothing. Still the same line in the same place going forever. Right? I mean, it doesn't affect it. So we okay with that? What if I had f of x equals 2 to the x minus 5? It's going to shift the graph right 5. So on the inside affects the x's. Inside does the opposite from what it looks like it's going to do. So this point that used to be at 0, 1, it's now going to be at 5, 1. 5, 1. And I can prove it. Plug in 5 for x. What would happen if you plugged in 5 for x? 5 minus 5 is 0. 2 to the 0 is 1. Okay. Yeah, that happens. What about that horizontal asymptote? It's the same graph, just moved right 5. You see how I just moved those points that I already knew? I moved them all right 5.
So the 3 has nothing to do with it until after, right? Like, you did the 2, and then the plus 3, or is that where the plus 3 is going to be? Like, you did the 2 graph
2 to the x.
before the plus 3, yes.
Yeah, this is the original,
Yeah, but,
the OG.
so do you do that first and then do the, whatever the plus is? Okay, so it don't have anything to do with like the factoring in and blah, blah, blah. Like, you don't do like 2 to the power plus 3, blah, whatever.
No.
Okay.
Just say no. I really don't know if I'm answering that correctly. I guess I'm going with no.